And welcome viewers from all around the world. We've seen a reduction in solar activity here over the past 24 hours. Geomagnetic storm conditions have shown up as a result of a coronal mass ejection strike. Also another massive coronal mass ejection to cover. That and tons more on today's daily space weather video. Thanks everybody for tuning in and stargazing with us here at the Smash News Network. Least busted name in news. This is your solar intensitygram, and again, we've seen a reduction here in sunspots and the radio flux over the past 24 hours. Here we've put up colorized magnetogram and 171 angstroms. Let's take a brief look at seismic activity. Largest quake of the past 24 was here very far north off the coast of Svalbard. That was a 5.9 magnitude earthquake. Coming in at 1840 Universal Time yesterday evening. So let's just scroll up the list here. There was a 5.1 in Afghanistan that likely caused some damage, as well as that 5.0 magnitude aftershock. Otherwise, things pretty calm here. Some quakes on the west coast of the U.S., but overall, fairly low levels of seismicity in the past 24 hours. Let's continue on to volcanoes. There's Sakurajima erupting behind some sort of a soccer stadium, it looks like. Sakurajima, the Japanese volcano there, remaining on the volcano list. So Shiveluch producing a 13,000-foot ash plume as Shiveluch explodes on the Kamchatka Peninsula. Sakurajima there generated a sudden, quite strong explosion with an 1,800-meter estimated ash cloud. Krakatoa, also exploding, one of the best names for a volcano. The daughter of Krakatoa, it's Krakatoa exploding, flight level 090. Fuego, flight level 160 in Guatemala. It's a 16,000-foot ash plume over the Central American nation. Moving farther south to South America, we see Sangay and Revenador both exploding. Flight level 190 from Sangay. Flight level 160, a 16,000-foot ash plume from Revenador. Not sure if Sabancaya is erupting or not. And let's get to the main feature here. The typical part of the content that we put on YouTube. Today, once again, 2 in a row, we're putting it all up in one video. So here's your 171 angstroms 24-hour video from SDO. And it looks like we do have another active region rising down here in the southeast. Once again, we've seen a reduction here of solar activity. Here's ionized helium as well. We've got a well-defined coronal hole system. We've got a huge coronal mass ejection to cover. We've got one striking the earthly geospace now and creating a geomagnetic storm condition. Auroras likely in large portions of the planet. The radio flux has come all the way down to 151 solar flux units. Make that 152 solar flux units. There's the 1-year chart of the radio flux to put it in context for you. That's a 1-year chart. This black line is the radio flux, and you can see how proportional that is to sunspot number, the red line below it. Space Weather Enthusiast dashboard here. NOAA choking on its forecast, not forecasting any geomagnetic storm or unrest conditions. We're expecting another geomagnetic storm or unrest condition tomorrow from a second coronal mass ejection strike. We'll get into the specifics of that momentarily. First, let's look at the last 4 hours of the space weather modeling framework. It's the depiction of Earth's magnetic moment from space. So this is modeling magnetohydrodynamic pressure out to about 12 Earth diameters. And we've got a high pressure environment as there is a coronal mass ejection strike currently happening. So here looking at Earth's magnetic moment from the ground, geospace ground magnetic perturbations. Those red spots are the most likely places to see aurorae, induction into power lines, induction into railways and pipelines as well. And we'll also show the 30-minute auroral forecast here. That's the last 4 hours of Earth's magnetic moment from the ground. And here's this great polar view, the 30-minute auroral forecast. Again, geomagnetic storm conditions. We are currently at a KP5. We'll get to the specifics of that momentarily. So here you should see this intensify. There you go. The growth of the auroral ovals, making it a lot more likely to see auroras in polar regions. So there's your KP index, a measurement of global geomagnetism. KP of 5 at the moment, a minor geomagnetic storm from a somewhat glancing blow, probably from the coronal mass ejection we talked about a few days ago. So covering it daily on the channel, immersing yourself in the data will yield answers for you. And one of the reasons that we're seeing geomagnetic storm conditions is this strong negative BZ signal. So that red line there being in the negative territory, we have a fairly strong field, but that strong negative BZ component is what's putting it over the top. We did make it up to 13 nanotesla there, and as strong as negative 11 as far as the BZ component. It looks like it's subsiding here, the way a glancing blow would be expected to do. Current solar wind density about 11 protons per cubic centimeter, solar wind speed 477 kilometers per second. It was a little faster than we expected. We were calling for a strike midday. Today it showed up early, actually late last night. So here are your GOES magnetometer readings over the past 3 days. And those spiky readings are typical of things like coronal hole high-speed streams and coronal mass ejections. Let's take a look at the heliospheric current sheet. Earth remains in a south pole current sheet shown there in red. Nothing to write home about there. Let's take a brief look at the fields. Here's our line of sight field plot showing the solar magnetogram, the sun's B field in blue, and the solar polar fields in red and green, south pole and north pole respectively. Next we'll look at coronal holes. We've got some very well-defined coronal holes. We can expect some high-speed geo-effective plasma coming from those in a few days as well. They are south pole oriented. And here's a great view of those in 193 angstroms. Spectacular imagery there of the source of high-speed coronal hole wind streams. South pole-oriented coronal hole systems. We'll move to sunspots next. And again, we've seen a reduction of sunspots, and a great reminder of the fact that we don't need to see sunspots or major solar flares to see coronal mass ejections. We've got another one to cover. Will it be directed at the Earth? Well, stay tuned. We'll cover it. So here's your sunspot analysis. We're down here to about 6 or 7 named sunspot groups. Again, there is a new active region rising in the southeast. We'll take a look at that toward the end of the video. And likelihood of solar flare still remains a bit high here, especially from sunspots like 3057, 3058, and 3059. Those are the most significant sunspot groups. So let's move to the 1700 angstroms view. This is the last 24 hours in extreme ultraviolet light. And we'll zoom in. And there you can see some mild degradation of sunspots. That is a 24-hour video once again from the SDO, the Solar Dynamics Observatory. So here's your X-ray profile over the past 3 days. Only C-class intensifications happening there. No major flares. The likelihood of large flares still remains, folks. Sunspots have been largely underperforming. There's your proton flux. No relativistic particles at the moment. If we do see solar flares, 94 angstroms is one of the better wavelengths to view them. It takes 10 images per minute instead of only 2. And 94 and 131 angstroms are specifically designed to observe solar flare activity. We've got a massive coronal mass ejection to cover, as well as one striking at the moment. So now Jupiter and the Moon are very close in the sky at the moment. If you're up before dawn, you may see that great show. Jupiter and the Moon very close to each other. That's our star chart from in-the-sky.org. And we encourage our viewers to go out and look up. Here's your solar system forecast. Here's where things will be in a week. We're approaching another new moon. We will have a crescent waning in 1 week's time. And there's an image that I took just this morning. Right out the front door there, the Moon and Jupiter showing up. That's on our Instagram page, instagram.com/smashamash. Go follow us over there if you haven't. Today's featured product is Mensa. Make Earth Not Suck Again. It's up to you. You got to push back against ridiculous ideas. If people don't push back against terrible bureaucratic decision-making will continue on. So make Earth not suck again. It's up to you. Each one of you must do your part to either obey or don't. Let us know in the comments what you've been doing to make Earth not suck again. Start a conversation by picking up some merch. Support the channel that way with some tangible items. It's a public service message. Make Earth not suck again. It's been sucking for pushing 3 years now. It's gotta end. Thanks to our YouTube subscribers for putting up with the pathetic censorship on the platform. Please press like and subscribe. We're not sure if the censorship will ever end, but we're hoping it does soon, as big tech needs to stop misleading investors. Smashamash.com is our homepage, and welcome to the Near Renaissance. Thanks especially to our Gold and Silver Smash Team members. If you want to support the channel via subscription services, become a member of the Smash Team at smashamash.com/Smash Team. There's what the page looks like. The GDEX Daily Reports are for only Gold and Silver level subscribers. This video was originally streamed live to Twitch, twitch.tv/smashamash, and let's get to the realm of coronagraphs. Yes, we've got some coronal mass ejections to cover once again, folks. Some coronal mass ejections. So this is yesterday's full day of coronagraphs from George Mason University. And there you can see that massive coronal mass ejection happening there late in the day. Is it directed toward Earth? We'll get to it. So here's today. You can see that coronal mass ejection is continuing at the moment. And let's take a look at some additional viewpoints here. We need the view from stereo A out here at Lagrange point 5. We'll also show the Soho-Lascaux C3 from Lagrange point 1. So we've paused this at about 3:45 universal time on the Soho-Lascaux C3 and at about 2 o'clock on the stereo A coronagraph. And it doesn't look like any of this ejecta is headed toward the Earth. Earth would be off on this line approximately from stereo A's perspective. And that coronal mass ejection appears to be south of planet Earth. So it's also a little bit off to the west, as you can see on the Soho-Lascaux C3. And this ejecta up here does not appear to be the same coronal mass ejection. That's looks like a separate event to me. But that's the situation. Let's let that play through. Bring those back. Let them play through on our coronagraphs before we go to our bonus features segment. Spectacular imagery there from stereo A and Soho-Lascaux C3 coronagraphs. We cover it on the regs, so you don't have to visit all the links yourself. Here's the hydrogen alpha imagery from El Teide, Spain. And we still do have lots of filaments on the Earth-facing portion of the solar disk. You can see all those dark regions. Those would be prominences if they were hanging off the edge, but they're not. They're in between Earth and Sun. We call them filaments. They're absorption features in terms of hydrogen alpha imagery. That's why they look dark. And they're much more atomically complex than just regular everyday hydrogen. You can see that active region rising in the southeast as well down here. Some filamentary behavior kicking off down there. So here's our GOES 16 SUVI. Let's zoom out a little bit. There we go. Great wide field of view from the GOES 16 SUVI. And we'll close out with some composite imagery. This is where our YouTube video typically ends, and we're putting it all together again today. Seems like people like longer videos on YouTube, maybe because the interface is so glitchy, buggy, and full of errors. This is a spectacular series of images from SDO. That's 171 plus 131 angstroms together. Makes for a very lively looking star. And once again, thanks for stargazing with us. So here come our bonus feature segment. This is usually a separate video. Today, it's all together. So this is the total electron content forecast showing the free electrons in between your GPS satellite and your handset. That's the free electrons up to about 12,500 miles of altitude, approximately where your GPS satellite's located. We've got some very anomalous areas of high electron content there. We typically see the highest electron contents around the equator at noon. Today, not so much. Feel free to pause the video on this diagram if you're interested in looking at that information. We've got to continue on. We don't want the video to be too long. We've got some charging hazards here, looking at the satellite's community dashboard. And we've got some surface charging hazards over northern South America, the Caribbean, Central America, Mexico, and moving into the Central Pacific Ocean. Those are caused by low-energy electrons building up on the surface of satellites. Shouldn't cause too much damage or communications breakdowns. Some minor ones may happen. So we see a cratering here of the electron flux. That's typical of a coronal hole high-speed stream, or in this case, a coronal mass ejection strike. That's the GOES 16 and 17's measurements using radiography from their geosynchronous orbits to measure the electron flux at the F ionosphere layer. So we're expecting a little bit lower levels here. We're expecting this to be down about here. And again, we typically see lower electron flux as a result of, or associated with, I should say, coronal mass ejection strikes or coronal hole high-speed streams. There's the one-year chart of the relativistic electrons from Solent.info. And next we'll show the F ionosphere layer ionogram. So here's the F ionosphere ionogram showing vibrational frequency. Each color blob there represents 1 megahertz of vibrational frequency, 1,000,000 vibrations per second. That's what a megahertz is. And don't be megahertz to realize that we're not suggesting that the ionosphere data can be used to forecast earthquakes. We just don't see it. And after covering it for the last 5+ years, we would see it if it was a thing. The resolution is too low, and it's just not there. So here's your anomalygram showing anomaly in megahertz from the 30-day median. We've got some high-frequency anomalies showing up here, showing up in blue. And let's bring up the latest images and move on. We're going to include the meteorology segment today once again as well. There's the latest ionogram, that's 10 o'clock Universal Time. There's the latest anomalygram from the same time, 10 o'clock UT. Here's our latest intensitygram of El Sol. And again, we do have another active region rising down here, and we've got a new sunspot. So there it is. We just showed it. There's a new sunspot. So far, it's only alpha class. But that'll be our next named sunspot group. Covering it as it happens here at the Smash News Network, least busted name in news. Again, a general degradation here of solar activity over the past 24 hours. Let's bring up a composite. This time we're going to show Iron Star. 3 different iron spectra there. 335, 193, and 94 angstroms. And we pride ourselves on showing you the most comprehensive space weather content and the most detailed imagery of the closest star on the entire internet. Congratulations on realizing the channel exists. It's time to move to the realm of meteorology. So we're starting things out here looking at space. And on nullschool.net, you can actually look at the likely spots for aurorae by clicking on Mode Space. We've got very likely aurorae there in the Southern Ocean. Nobody probably able to see those. And there's the auroral oval for the North Polar region. Certainly some Alaskan aurorae there visible. That's the current state of affairs. It is a geomagnetic storm condition. So let's go to the regularly scheduled jet streams and surface winds. There are the jet streams of the eastern world, still blowing backward over the western Pacific and northern Indian Oceans. Strong jet stream signal there over Australia. Here are the surface winds of that side of the planet. Let's look at the Americas. There are the surface winds of the Americas. We've got a huge heat dome and a high pressure system over the U.S. There is an anticyclone rotating clockwise big time over the U.S., and you'll see it here when we look at the jet streams. There are the jet streams. You can see that clockwise rotation there, causing convective forces to largely be at play in the southern portion of the U.S., the jet stream staying north of the United States. Strong jet streams there in the southern hemispheric winter of South America. Here are the jet streams of Europe, Africa, and the Middle East. Some cold air blowing down into places like Eastern Europe. You see some cold Arctic air blowing its way down there. Here are the surface winds of this portion of the planet. And let's blast through some more weather information. Here's your US weather.gov map. Head to weather.gov. If your county is lit, click your county. Those are heat advisories in places like Texas and most of Oklahoma. Continued gale warnings there around Hawaii. Oh my God, who's seen the video on Twitter about the giant wave in Hawaii? Oh my God, it must be caused by global warming. Your SUV and all of that carbon dioxide coming out of the tailpipe must have caused a wave to disrupt a wedding in Hawaii. Sorry about that. That's your weather.gov map. Again, if your county is lit, click your county. Here's your NASA Goes Lightning Mapper. July being the most active month for lightning planet-wide. Here is your real-time lightning map from lightningmaps.org. And we had some severe thunderstorms here in Pennsylvania. Shout out to Reed Timmer. He was absolutely correct. As some sudden cloud nucleation indeed occurred, striking large portions of eastern Pennsylvania with some severe thunderstorms. Anyway, that's your current situation. Let's check on some terrestrial lightning. Heavy storms are around the U.S.-Canadian border. And it looks like we've got some terrestrial strikes here in the southern U.S. Atlanta, looks like you might be in the crosshairs for additional thunderstorm activity. Continuing on, here's your temperature anomaly forecast based on the GFS model for the next 72 hours. Some isolated pockets of both hot and cold temperatures showing up there in the south central U.S. Some wild gyrations of temperatures happening. Again, that's your GFS 72-hour pressure and your GFS 72-hour temperature anomaly forecast. Here's your GFS pressure and precipitation forecast. Again, it's 72 hours worth of GFS forecast. Looks like some heavy weather showing up there in northern Mexico. Lake Superior, it's going to be pretty stormy in the coming days. All right, let's continue on here. Let's show your European forecast. This is the European model forecast for temperature. We're just going to let that play through briefly. That's from windy.com. They got a great mobile app, by the way. Check that out if you like. I use it on the regs. This is the way we expect temperature to play out based on the European model. And we'll pause this midday Thursday. So there's where things will be at 1300 Universal Time on Thursday. Here's your U.S. Doppler radar map. And let's zoom out briefly to show Hawaii and Alaska. Looks like some July snow falling in central Alaska. Here's your shortwave radiation map. That's a 3.9 nanometer satellite infrared radiation. And there's the water vapor. Some rapid cloud nucleation and some sudden rain happening there over eastern Arkansas. Here's your recap. It's time to close this thing out. Vertical motion of water droplets in the air column detected by ground-based systems known as Doppler radar. Shortwave radiation map on the NASA GOES Interactive Weather Satellite Suite showing clouds and fog. And there's water vapor. That's where we'll close things out. Thanks for tuning in to the Earth and Space Weather Together. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.